So, function operations. This is a function, f of x, that's function notation. 2x plus 3, this is actually a linear function, okay? This is a function. That's a function, right? We have done every single function operation except composition of functions. We've done everything, okay? We didn't say, hey, this is a function operation. We've done it all. We've added them, f of x plus g of x. We've done that, right? That would just be this one plus that one, which would be what? X squared 9. So we've added them. We've done that. That's not new, right? We've subtracted them. How about, mix it up, g of x minus f of x, x squared plus 6 minus 2x plus 3. That would be x squared minus 2x plus 3. We've done that. We've multiplied functions. 2x plus 3 times x squared plus 6. How do I multiply that? Yep. 2x to the third plus 12x plus 3x squared plus 18. Can't be simplified, but we can at least make it a little bit neater. And I think everyone's personal favorite is dividing functions, right? Everyone loves that one the most? No? What? You don't? G of x divided by f of x. What times 2x gets me x squared? 1/2 x. And that's going to be a negative 3/2 x plus 6. So I'm going to have to multiply 2 times a negative. I need it to get it to be 3/2. What times 2 gets me 3/2? What times 2 gets me 3/2? Times what equals 3/2? What is going to be 3/4? Is that what you said? And then let's finish that up. Okay, so all of that is old stuff, right? We know how to do all of those things. We know how to add, subtract, multiply, and divide. Yes? Multiplication could also look like this, just a way to write it. To write it like that. Okay? And division could also look like this. All those are old news. Alright? What we haven't done yet, that we really want to focus on today, is composition of functions. Okay? Composing functions. That's the new stuff. composition of functions is where you take two functions and you actually put one of them inside the other. Okay? So, just an example. Let's say you've got f of x equals, what was that, 2x plus 3? And you wanted to find f of 5. Do you know what you do with the 5? Put the 5 in for x. Okay, so that would be 2 times 5 plus 3, which is 13. Alright, so we're going to do that, but instead of that being a number, it's going to be another function. Okay? What was x squared? What? Plus 6? Okay. So composition would say, okay, find f of g of x. And you would see how g is on the inside. You would literally put g inside the f. So it would be 2. Now there's an x. So where there's an x, I'm going to put this, which is x squared plus 6, and then plus 3. Follow your order of operations. 2 times x squared is 2x squared. 2 times 6 is 12. 12 plus 3 is 15. That's your composition of functions. Okay? Now, you know how like 2 times 3 is 6 and 6 times and 3 times 2 is 6, or 4 plus 7 is 11 and 7 plus 4 is 11. You can switch those around. They are commutative. Composition of functions is not commutative. Okay? Look what happens if we do g of f of x. I have to immediately take f of x and square it. See, it says, hey, square x, and then add 6. Okay, 2x plus 3 squared is, it's a Monday morning, but I'm going to try and do this in my head. 4x squared plus 12x plus 9 plus 6, which is not the same. Composition of functions, order is very important. If you accidentally put the wrong one inside of the other one, then you're going to end up being wrong. Okay? So I'm going to give you a pretty easy one to practice on. And I would like for you to find q of h of x. Oh, and it can also have this little circle thing. It's like an open circle. Let me see if you have those in your book. Yes, you do. Okay. Or, that's what it looks like right there. H of q. So the q goes inside the h. That's what it looks like. So find q of h and h of q. Alright, find those two on your own. Alright, so on this one, what should I write down first?
No.
3x minus 4 plus 7. Right, because see, I'm putting h inside of q, so wherever I see an x inside of q, I have to put all of this. Alright, so that's going to be, what, 3x plus 3? And that's your answer? Alright? Alright, what about over here? What should I write first? 3. Parenthesis x plus 7 minus 4. Yeah. So 3x plus 21 minus 4 would be 3x plus 17. Did you get it? Good, good, good. Yep, I'm going to give you another practice. Do I have that right? This is pretty much it. I'm going to give you some numbers to put in there, but it's still like once you figure it out, then you put in a 2, and you're like 3 times 2 plus 17. So it's like 6. Yeah, yeah, it's pretty easy. Yeah. You don't trust it? That's so funny. I guess I could make it hideous, like I throw some fractions in or something. No? No, thank you. Okay. Well, I mean, you know. Okay, here, this one, alright. This is gonna be a hard one. Alright, so this one is a little bit different because what's happening here? You gotta put it in twice. Right. You have to put it in 2 for both of the x's. But that's really the only difference. So, okay, there you go. Okay. So on this one, g goes inside of f. Right? So it starts out with x squared. So that means that's x minus 5 squared plus 3 times x, which is x minus 5, plus 4. Square this. I'm going to get x squared minus 10x plus 25. Distribute 3x minus 15, and then plus 4. And then just combine your like terms. Let's see, I got x squared minus 7x. That's going to be 10 plus 14. Is that right? There's your answer right there. Okay. Now this one's a lot easier, right? Because you put the long problem inside the little problem. So x minus 5, well, x is x squared plus 3x plus 4. Oh, minus 5. X squared plus 3x minus 1. And there you go. Okay? Easy stuff, right? Okay, let's keep these same 2 up here. And what if we had g of f of 2 and, well, let's start with that. G of f of 2, what would I do with that? Put the 2 in for x. Where? Which one of these? One on the right. Okay, so 2 squared plus 3 times 2 minus 1. It's going to be 4 plus 6 minus 1, 9. About f of g of, I don't know, 5. What would that be? Like you already know it's 22.
No, it says 42 is like the number to put in there.
Oh, okay. 39. I'm going to have 5 squared minus 7 times 5.
Oh, wait, no, I did the other one. So.
Plus 14. So that's 25 minus 35, which is negative 10, plus 14, so it's 4.
Well, if you were to put 5 in that other one, x squared plus 3x minus 1, it'd be 39.
Oh, okay. Awesome. Again, proving they're not the same. And you do, when you switch around those inverse functions, you're not going to get the same answer. Okay?
So what you're doing is you're like, first you find like g of f, And then after you do that, then you would plug in 2 for any of the x associated functions.
Exactly. Yes.
Got
Exactly.
a ratio.
Super easy, right? Okay. And then rainbow. And you can keep your notepad.